Hello students, in my last classes we have learned the two important concepts, okay, enthalpy change delta H and internal energy change delta U. Then today I am going to derive a mathematical equation connecting delta H and delta U, okay? That is the relationship between delta H and delta U. Yes, please listen. In order to develop a relationship between delta H and delta U, let us consider a gaseous reaction carried out at a constant temperature and pressure. Yes, here the gaseous reactant A is converted to gaseous product B. Yes, suppose this reaction is carried out at a constant temperature and pressure. Okay, at a constant temperature and pressure. Then suppose during this reaction the volume is changed from VA to VB, and yes, let NA and NB be the number of moles of gaseous reactants A and the gaseous product B respectively. Suppose these two gases A and B behave ideally, that means these gases obey the ideal gas equation. Then according to ideal gas equation, in the case of gas A we can write PVA equal to NART, equation 1, and in the case of the gas B, PVB equal to NBRT, equation 2. Then equation 2 minus equation 1 we get PVB minus PVA, here P is common, then P into VB minus VA equal to NBRT minus NART, RT is common, then NB minus NA into RT. That is P delta V equal to NB minus NA, number of moles of the gaseous product minus number of moles of the gaseous reactant, yes, which gives a change in the number of moles of gases, that is delta Ng. P delta V equal to delta Ng RT. Okay, then already we have learned a mathematical expression at a constant temperature and pressure, okay, that is delta H equal to delta U plus P delta V. Okay, delta H equal to delta U plus P delta V. Yes, P delta V equal to delta NGRT. Equation is equation 3 ആയിട്ട് consider ചെയ്യാം. Then this equation is taken as equation 4. Then we can substitute equation 3 in equation 4. Substitute equation 3 in equation 4. We get delta H equal to delta U plus delta NGRT. Yes, this is the mathematical expression between delta H and delta U. Delta H equal to enthalpy change in delta H is equal to delta U plus delta NGRT. Okay. Then here delta Ng means what? Changing the number of moles of gases, that is number of moles of the gaseous product minus number of moles of the gaseous reactant. ഇനി നമുക്ക് ഈ ഇക്വേഷനുമായിട്ട് ബന്ധപ്പെട്ട 3 കേസുകൾ കൺസിഡർ ചെയ്യാം. Case 1, please listen. When number of moles of the gaseous product is equal to number of moles of the gaseous reactant, then delta Ng equal to 0. Okay, delta Ng equal to 0. Then in this case, the relationship between delta H and delta U, that is a delta H equal to delta U. That means if you conduct this type of reactions at a constant pressure or at a constant volume, the energy change will be same. Delta H equal to delta U, or we can say that QP equal to QV. Yes. Example, H2 gas plus I2 gas gives 2HI gas. Okay. Here the number of moles of the gaseous reactant, 2 mole, 1 mole H2 and 1 mole I2. 2 moles of reactants are involved in this reaction. Then 2 moles of the products are formed during the reaction. Then here delta Ng equal to 0. Then delta H equal to delta U. Then case 2, when number of moles of the gaseous product is greater than number of moles of the gaseous reactant, then delta Ng becomes positive. Okay, delta Ng becomes positive. Here the value of delta H is greater than delta U. For example, we can consider a reaction, decomposition of ammonia. When ammonia gas get decomposed to form nitrogen gas and 3 moles of hydrogen gas. Here the number of moles of gaseous product is 4. 1 mole of nitrogen and 3 moles of hydrogen. 1 plus 3, 4 moles, and number of moles of gaseous reactant is 2 mole. Then here we can say that the number of moles of gaseous product is greater than number of moles of the gaseous reactant. Then in this case, the delta Ng is positive, then the value of delta H is greater than delta U. Then case 3, when number of moles of gaseous product is less than number of moles of the gaseous reactant, then delta Ng equal to negative. Okay, delta Ng equal to negative. Then we can say that the value of delta H less than delta U. Example, yes, we can reverse this reaction. Okay, then N2 gas plus, okay, 3H2 gas forms 2 moles of ammonia gas. Well, ഈ പറഞ്ഞ കാര്യങ്ങളിൽ നിന്ന് നമുക്ക് അല്ലേ പ്രധാനമായിട്ടുള്ള 3 കാര്യങ്ങൾ നമുക്ക് പറയാൻ പറ്റും. The first point, when delta Ng is equal to 0, delta H equal to delta U. When delta Ng is positive, delta H is greater than delta U. Then when delta Ng is negative, delta H less than delta U. Okay, students, in my next video, I will discuss the next important topic from this chapter, enthalpy of reactions. Okay, students, goodbye, study well.